Hello guys, welcome back to Civil Engineering Tutor. In this video, I am going to discuss some important questions from steel design and I will explain them as well. And this video is going to be very much helpful for all the aspirants who are preparing for competitive exams like SSC JE, GATE, RRB JE or different state public service commission, junior engineer and assistant engineer exams. So let's start this video. Here is question number 1. The maximum permissible stress for power driven field rivet in bearing on rivet is, 4 options is given. So before checking the correct answer for this question, here you have to remember that this is for power driven and the condition is field rivet. So this rivet is fabricated in field, not in workshop. So here is the reference. The correct answer for this case is 270 megapascal, and we can see that generally rivet is fabricated in two ways. One is power driven and another is hand driven, and again in power driven it can be fabricated in workshop or in field. So when in this problem it is given that for field rivet. So for field rivet under bearing condition we can see the bearing stress or permissible stress is 270 megapascal. So questions may be asked from different part like what is the permissible stress for axial tension for shop rivet or power driven shop rivet. So for that case answer will be 100 megapascal. So note it down and try to remember this table. Question number 2. The maximum center to center distance between rivets in a tension member of thickness 10 mm is. So thickness is given. Now center to center distance we need to find. So here is the reference for this question, that center to center distance between rivets shall not exceed 16 T or 200 mm, whichever is less. Here T is the thickness of the thinner member. Always remember this is thickness of thinner member. So here in this case only one thickness is given, but if two plates thickness is given like 10 mm and 8 mm, so in that case we will use the lowest one or the thinner one, 8 mm in that case. But in this problem we have only one thickness, that is 10 mm. So simply we will put 16 T is equal to 160, 16 multiplied by 10, and that will be 160 mm or 200 mm, and we have to select the lesser value. So obviously lesser value is 160 mm. So the correct answer for this case will be 160 mm. Question number 3. The effective slenderness ratio of last column compared to actual maximum slenderness ratio shall be considered as. 4 options are given. So here this is for lacing, that can be for batten also. So for you have to remember this formula, that for laced column and for batten column. For laced column we have to increase the slenderness ratio by 5%, that is 1.05 we need to multiply, and for batten column this is increased by 10% or it is multiplied by 1.1 times. So you have to remember this way question may be asked, that the slenderness ratio is increased by, you have like 5%, 10%, 20% or kind of options. So in this case for laced column it is 5% and for batten column it is 10%. So here correct answer is laced column, so correct answer will be 1.05 times. For simply supported beams the maximum permitted deflection is 1 by 250 of the span. These are options given. So just remember that for steel structure the maximum permissible deflection for simply supported condition is 1 by 325 of the span. So here correct answer will be none of this. Okay. Moving towards next question. The heaviest I section for the same depth is ISLB. If you know the full form of these 4 terms, then obviously you will get the correct answer. And here heaviest they have asked, and we can see H is there. So H is stands for heavy. So here is the full form of all the sections I can say, and simply by knowing the full form you can understand which one is the heaviest. So ISLB is the lightweight beam, MB is the medium weight beam, and HB is the heavyweight beam. So correct answer will be ISHB. Now question number 6. In factory buildings the horizontal beams spanning between the wall columns supporting a wall covering are called stringers, trimmers, grids, purlins. So here you need to remember one thing, that this is horizontal beams, number one thing, and this is for wall covering. So there are two cases, one is for wall covering and another is for roof covering, and accordingly there are two members. one is called purlin and one is called girts. So you need to understand that which one is purlin is for whether it is roof covering or wall covering, and girts it is for wall covering or roof covering. So here is the explanation. So generally girts, this is used for wall covering, and or you can say guards also sometimes, and purlins is generally for roof covering. So the correct answer for this question will be guards or girts, whatever pronunciation you can. So question number 6, correct answer is C. And here is the pictorial diagram. You can see that this is purlin. So this is a roof covering, and purlin is the horizontal beam that is supporting this roof covering. Another way, guard or girts is also horizontal beams, but it is supporting the wall coverings. So just remember this thing. So this is wall, you can see. So when wall is used, in that case girt will be used, and for roof covering there will be purlin. Okay, so remember this. Question number 7, center to center distance between center to center distance of adjacent rivet or bolt holes measured in the direction of stress is called. So here they have asked that in the direction of stress, center to center distance is known as gauge, pitch, lap or edge distance. So here correct answer will be pitch, because you can see in this pictorial diagram that this the direction of application of stress is given. This is acting in this direction. So the center to center distance in the direction of stress, this is known as pitch, and perpendicular to that this is known as gauge. Okay, so this is stress and this direction is perpendicular to stress application, so this is known as gauge. But this direction or this distance or is like parallel to the application of stress, so this is called pitch. Okay, so just try to remember this picture and you can easily understand what is pitch and what is gauge. So pitch is in the direction of stress and gauge is perpendicular to the direction of stress. Question number 8, the diameter of a rivet connecting plate of thickness 60 mm given by Unwin's formula is. So I think this is very basic question, and all of you who have studied steel design for at least one times, you must be knowing the formula of Unwin's. And Unwin's formula is like this: 6.05 root over T. Here T is the thickness of the connecting plate, which is 16 mm. So simply putting the value 6.05 root over 16 will get the correct answer, and the correct answer will be 24 mm. Question number 9, which of the following elements of a pitched roof industrial steel building primarily resist lateral load parallel to the ridge? Bracings, purlins, truss, columns. So here you have to understand the key term here, that lateral load. Okay, so which one is resist lateral loads? So purlin, we can simply say that purlin used for roof covering, so there is no point of lateral loads there. Truss and column is also for axial load, so correct answer in this case will be bracings. So remember this, that bracings are generally provided to resist lateral load. Now before moving towards final question of this session, if this video is anyway helpful in your preparation, please like the video and subscribe to the channel, and you can comment down whether I need to improve the quality of questions or the should I need to select more hard questions, or is it okay. So your feedback is necessary, so please comment if you think that anything I need to improve with the contents, then please do comment. In rolled steel beams, shear force is mostly resisted by. So we know that any rolled steel beams, there are two specific portions, one is called, or specific parts, one is called web and another is flange. So here shear force is mainly resisted by which portion? So here is the explanation, that shear is mainly resisted by web and bending is mainly resisted by flanges. So here you can see this is flange portion and this is web portion. So this portion, web portion, is generally resist shear and this flange portion resist bending. So that's it for today. Thank you very much for watching this video.